This GP model is the most productive and comfortable grader in the industry. When properly set up, operators are truly amazed by its capabilities. One of those capabilities is the cross-slope feature. This system reduces operator fatigue and improves accuracy. The operator can set a specific blade slope angle that the machine will maintain, while the operator determines the blade height on the toe side of the blade. The operator usually references a curb line, grade hubs, or the shoulder of the road. The calibration of this system is extremely important for peak performance. Some of the common reasons to perform calibrations are whenever cutting edges wear or they are replaced, whenever tire pressures change or tires are replaced, whenever the blade side shift wear inserts are adjusted, whenever the draft frame or circle wear inserts are replaced, whenever a sensor, controller, hydraulic cylinder, or valve is replaced. But more commonly, it's whenever the system no longer cuts the correct slope. This program will identify the major components of the cross-slope system and demonstrate the step-by-step process to calibrate them. The system relies on input from 3 sensors to control the hydraulic blade lift cylinders for positioning the draft frame. The roll and pitch sensor is located in the front of the draft frame. It is visible by removing the top cover. It tells the machine's computer what the draft frame side-to-side roll is and what the fore and aft pitch is, both of these in relation to gravity. The second sensor is located here on the rotary manifold. It measures the rotational angle of the circle frame relative to the draft frame, so the moldboard can hold the desired slope regardless of how the circle is positioned. The third sensor is located here, underneath the cab mounted to the mainframe. It's called the main fall sensor and tells the computer if the machine is going up or down a hill. Together, these 3 sensors provide all the information that the cross-slope system needs to determine the position of the moldboard in space. The grader's monitor is used to guide the operator through the steps needed for the various calibrations. Press the middle button once to enter the monitor menus. Use the arrows to scroll down to the Machine Configuration menu and press Select. On this screen, you will see 2 options that are specific to the GP models: cross-slope sensor cals and GP valve cals. In this menu, there are 4 different calibrations available: roll cal, circle rotate cal, pitch cal, and a combined roll and pitch cal. This program will focus only on the combined roll and pitch cal and the circle rotate cal. That's because if you understand how to do these, you will be able to perform any of the calibrations listed. Let's begin by performing the combined roll and pitch calibration. For best results, locate a hard, flat surface, such as a concrete pad, and park the machine on it. If you're located in a confined area, it's best to initially back the machine onto the pad. This allows for easier positioning of the machine later in the procedure. Once the grader is in place, raise all front and rear attachments off the ground. Select Roll and Pitch Cal from the menu. This will calibrate the sensors on the draft frame and under the cab. After reviewing the procedure in the operator's manual, press Select. Following the monitor instructions, align the front and rear frames so they are straight, and install the articulation locking pin. Turn the wheels so they are straight. Set the wheel lean angle to 0. Note that due to geometry, there will be a small amount of tilt even when the wheels are at zero lean. Just be sure that the right and left side angles match. Adjust the blade side shift so the blade is centered. Pitch the blade all the way back. Press select. Side shift the circle so you'll have a good view of the notch on the left rear of the draft frame. Align the notch to the outside surface of the left support arm that holds the blade. Position the blade approximately 1 to 2 inches or 25 to 50 millimeters off the ground. Now, side shift the circle to center the draft frame under the machine. The lean of the lift cylinders are equal when the draft frame is centered. For improved accuracy, place 2 pieces of steel like these underneath each end of the blade. For best results, place them the same distance from the end of the blade on each side. Once the pieces are in place, press both blade float switch buttons to float the blade to the ground. Press select. Now mark the ground using duct tape or fluorescent spray paint on the outside edge of the front left wheel. Also mark the center of the hub. Mark the end of the blade. Mark the outside of the tandems and in between the 2 rear wheels. Now mark the wheels and blade on the other side. After marking, return to the cab and press select. Position the blade all the way up. You will need to readjust the circle side shift to allow maximum raise of the draft frame. Press select. Turn the machine around 180 degrees so it's facing the opposite direction. Do not touch any of the hydraulic control levers except for front steering while turning the machine around. Align the front wheels with the marks made for the center of the rear tandems, and align the center of the rear tandems with the marks made for the front wheels. Press select. Now back the machine up and begin lowering the blade so that it will be set in the same spot on the steel blocks that you placed down earlier. Small adjustments of blade side shift may be made as required to ensure that the ends of the blade are positioned in the same spot as the blade was previously positioned. Press select. Position the blade approximately 1 to 2 inches or 25 to 50 millimeters off the ground. Press the blade float switch buttons to float the blade down. Press select. The monitor now displays calibration successful, and the roll and pitch calibration process is complete. Contact your local dealer or DTAC if you encounter problems. Press select to continue. We will now perform the circle rotate cal for the circle rotate sensor on the rotary manifold. To begin, attach a small piece of paper, such as a business card, to the outer surface of the circle arm using a piece of duct tape like this. This will act as a pointer so that you can easily see when the circle is properly aligned. Press select with the circle rotate cal highlighted. Again, after reviewing the procedure in the operator's manual, press select. Use the circle side shift lever to shift the draft frame to the right to allow better visibility of the alignment notch. Press select. Now rotate the blade approximately 15 degrees to the right or clockwise. Press select. Then slowly rotate the blade back toward the center until the notch of the draft frame is aligned with the outside surface of the left supporting arm, or align the notch to the card that you taped on earlier. If you accidentally rotate past the notch, again reposition the blade at approximately 15 degrees to the right and try again. Press select. Now, position the blade so that it's rotated approximately 15 degrees to the left or counterclockwise. Press select. Now slowly rotate the blade back towards the center until the notch on the draft frame is aligned with the outside surface of the left supporting arm, or align the notch to the card that you taped on earlier. Just like before, if you accidentally rotate past the notch, reposition the blade approximately 15 degrees to the left and try again. Press select. Calibration successful will be displayed, and the calibration process is complete for all the cross-slope sensors. Next, we will demonstrate how to calibrate the hydraulic valves. Over time, as the hydraulic valves are used, the amount of force that it takes to move each valve will change. This means that the amount of lever movement will change as well. To compensate for this and keep all levers feeling the same, you must periodically calibrate the hydraulic valves. This procedure should be done whenever the operator notices inconsistent response from function to function, a change in the response of a function over time, or when the blade hunts up and down when using the cross-slope feature. Calibration is also needed when a hydraulic valve section or other hydraulic valve components have been replaced. To begin the calibration process, park the machine on a level surface. Warm the hydraulic oil to at least 100 degrees Fahrenheit or 38 degrees Celsius. With a cold machine, this can be done by holding a function over relief while operating the circle rotate function back and forth. This forces the system to run at maximum pressure and maximum flow, which will warm the oil quickly. While warming, you can monitor the oil temperature by pressing the middle button on the top of the display monitor and scrolling down to the Diagnostics menu. After pressing Select, scroll down and select Hydraulic Sensors. On this screen, you will see the hydraulic oil temperature. After the oil has reached the proper temperature, you must cycle all of the hydraulic functions several times to distribute the warm oil out to the various valves and cylinders. This is important. Just because the oil in the reservoir is warm does not mean the oil in the valves and cylinders is warm too. Now, set the engine speed to 1600 RPM by using the engine speed control switches on the right console. Make sure both armrests are down, and the hydraulics are enabled on the sealed switch module. Also make sure that the cross-slope and electronic grade control systems are disabled. Use the buttons on the monitor to access the machine configuration menu. Select GP valve cals and then decide which functions you want to calibrate. Each function is calibrated individually and can be done in any order. Hydraulic calibration involves fully extending and fully retracting the cylinders based on the monitor instructions. We will calibrate the left and right blade lift cylinders because these have the most impact on cross-slope performance. We will select the left blade lift calibration and press Select. The monitor will define how the function should be positioned. It is very important to follow these instructions because failure to properly position the function will cause an incorrect calibration. For the blade lifts, the saddle will need to be moved to the bank position to fully extend and retract the blade lift cylinders. For the left cylinder, the saddle needs to be moved to the right bank cut position. Do not simply raise the machine off the ground. The excess weight on the cylinders will result in an inaccurate calibration. If the operator is not comfortable with moving the saddle, contact DTAC for an alternative solution. Once the left lift cylinder is fully extended, press Select on the monitor to continue calibration. Note: do not actuate any hydraulic functions during the calibration ramping sequence unless instructed to do so by the monitor. If for some reason you want to abort the hydraulic calibration procedure, press back on the monitor. Once complete, reposition the function as defined on the monitor, which in this case is to retract the cylinder fully. Once the cylinder is retracted fully, press Select. Again, do not actuate any hydraulic functions during the calibration ramping sequence. Calibration values are saved once the monitor displays calibration successful. Now return to the previous screen and select Right Lift Cylinder Cal. To fully extend the right lift cylinder, the saddle must be positioned into the left bank cut position. Once extended fully, press Select and wait for further instructions in the monitor. Once the right lift cylinder is fully retracted, press Select and continue the calibration. When calibration successful is displayed, the calibration is complete. If calibration fails, verify that the function is properly positioned and that no hydraulic function was actuated during the ramping sequence. If the problem persists, contact the dealer or DTAC. Now, for a quick review. Cross-slope calibration involves sensors, as well as the hydraulic cylinders. The monitor is used in combination with the grader functions to calibrate the roll, pitch, and circle rotation. The monitor is also used to step through the calibration of the hydraulic valves. Remember, do not take shortcuts with these procedures. The more careful you are when doing these calibrations, the better the chance your machine will be accurate and will exceed the operator's expectations.